Hi everyone, Greg here. In this video, I'm going to show you how to write your own website in C. The first question you might ask yourself is why? Why would you do that? Why would you not use PHP, which seems to be the main way of doing this nowadays? There are a couple of reasons, and the first one is simply to future-proof your code. I do remember the late 90s, the early noughties. Perl was the king of the web before PHP. Perl was the king of the web, and at the height of the popularity of Perl, you could do just about anything in Perl. There was a Perl module for just about any database that you could think of. There was a Perl module for just about every GUI that you could think of. There were language bindings so that you could use any other programming language that you could think of with Perl. So Perl was the king, and it seemed unthinkable all the way until the early noughties that Perl would ever disappear, and yet it did, and when it did so fairly quickly. And there were two main reasons why it did. Is number one, PHP became very popular and just took over as the language of the web. And the other thing is that when the community wanted to create Perl 6, there was a schism in the Perl community. Part of the community wanted to rewrite Perl 6 from scratch, and the other part of the community wanted to continue with the code base that they had. The part of the community that wanted to rewrite everything realized that when you do rewrite, it always takes longer than you anticipated, and things just went downhill from there. So it was unthinkable for Perl to disappear, and it is unthinkable for languages today, languages like PHP, languages like Python. It is unthinkable for them to disappear today, but you really don't know what's going to happen in the future. When it comes to C, I guess you can't be sure either, but C has been around a long time. It's been around since the 1970s, and I don't see it go anywhere. So I'm very confident that my C code will continue to work for a very long time in the future. So that's a first reason. The other reason is that when you use PHP or maybe Node.js nowadays, or whatever it is, whatever the new kid on the block is, you're dealing with a lot of bloat, a lot of code, and all of that code leads to an increased chance of a vulnerability somewhere in that code. The least code that runs on your system usually means that the code is more secure. Of course, you have to do your own part to write your own C code in a way that is secure. But usually when you have less code, it means that the whole thing is more secure overall. The cost is less when you code in C because you're closer to the metal. There are fewer instructions to be run, so you need less computing power. And so that means that with a given set of hardware, you can provide to more users when you write in C rather than the more bloated languages. Also, when you have fewer instructions to be performed, it means you're also spending less on electricity. Now, for small websites, that might not matter, but those tiny differences, those tiny increases in required computing power, they add up. Then also it means when you write in C, your code base is more reusable. If you code in PHP, you're probably using PHP only on the web. If you code in C, you might have a code base that is used for binary programs locally, and then you might be able to reuse some of that code for your website, and it just means your code is more useful overall. A good thing to do as a C programmer is to create your own personal library. As a programmer, you will develop your own style. There are problems you will come across over and over again. You will develop a certain approach to problem solving. You will save a lot of time if you create your own personal library with those low-level functions that you use all the time. Sean Barrett talks about this in a video of his. I talked in my video on recursion about different levels of proficiency among programmers. Sean Barrett is someone I would consider a grandmaster of code. He has this video where he explains his approach to coding. The TLDR is that, or at least my read of it, is that you should develop your own library for the stuff you do frequently, so you have this growing code base you can rely on to solve problems in the future. By doing as much as possible in C, you increase the chance that you will be able to reuse code later. Also, by having a lot of low-level functions thoroughly tested in your personal toolbox, coding in C can start to feel like you code in a high-level language. I have my own personal library. I call it Technical. I know it's a very original name, but I will be referring to it again in a minute. So you might think it's difficult to write CGI in C. PHP does take care of a lot of things behind the scenes. That might be true at first, but once you understand a couple of simple concepts and once you're past that first hump, it's really easy to do it in C. So what I'm going to do is I'm going to provide you with a very simple library that will get you started. So if you're going to do stuff in CGI, you may have to configure your web server in order to allow for that. Details vary here depending on which type of software you're using. So what I need to do in my situation is I use Apache 2. So I just need to ensure that this bit of scripting here is included in this file. And then I reload Apache with this command, and that should take care of it. Okay, in order to write CGI, you need to have some basic understanding of how an internet connection works. So when you decide to look at a website, if you decide to go to google.com, for example, your browser will send out an HTTP request and will ask Google to send the home page. Well, in order to support that request being sent, there's various layers underneath that basically make this happen. So the hardware provides you with a protocol being Wi-Fi or Ethernet. Each one of those layers will add its own header to the data that is being sent out. So the hardware takes care of this bit. The IP, the Internet Protocol, deals with routing. So routing basically deals with the data finding its destination on the internet. The kernel will take care of that layer for you, and the same is true for TCP. What TCP does, it's basically accounts for all the packets. It's not necessarily all going through the wire in one chunk. It can be split up into different packets, and if a particular packet has not reached its destination within a certain time delay, then that packet will be sent again. And this basically makes sure that the totality of the data reach its destination without errors. So now when you write CGI, you are responsible for this layer yourself. The HTTP headers is something you will have to write yourself. It is a very simple thing to do. You'll see it in a minute. But it's just something to be aware of, that this is something that PHP would give you for free and that you actually have to do yourself when you write CGI. Okay, so what I just did is I SSH'd into my web server. I am going to create a file, web.h. Okay, so that's very standard. And I'm going to create a simple way of doing the header. So every function that's part of the API, I will prefix it with web print header. And this is going to be simply a printf. Now everything I do is in UTF-8, so I like to put that in the HTTP header so the browser knows everything is in UTF-8, and I'm not going to have any issues with things not being displayed correctly in the browser. So that's all I need to start me off. So I'm just going to save that. Now I'm gonna write a main.c. Hold on. I'm going to call it hello.c. I'm including my web library here, and this is going to be a simple hello world program to test that everything is working the way I expected. So web print header, and then I'm going to have just hello world. And then compiling it is very simple. hello.c. Okay, CGI test, and then hello. And then sure enough, I see my hello world. Okay, what is another thing I may want to do? I may want to relocate a web page. So if you go to one page, it automatically directs you to another. That's also a thing that's fairly easy to do. So we go back here. Here we do web print relocate header, and it will take an argument which is simply the URL you want to relocate to. We do printf. There we are. And now I'm going to do a new test page. So I'm going to do relocate.c. And what are we doing here? We do web print relocate header. How can we relocate to, let's say, Google? So I need to compile. Yeah, very good. And now if I go to relocate, this is sending me to Google. Okay, so that was nice and easy. Now, how would you deal with something like a query string? Well, the query string will actually show up in the environment variables. Okay, so the environment variables is something that you can very easily have a look at. Again, a very simple piece of code. You see here environment, and I am just going through this array of strings and I'm just printing them all out. When we then look at what that looks like in the browser, we see all of those different environment variables, and we see here the query string, which right now is empty. So what if I add a query string here? Then we refresh the page and we see that the query string here has shown up. So whatever comes after that question mark is the query string. All right, so this is again web.h. You can see there's a lot more going on here now. I have web get query string. So this will take the query string and it will process the string into those individual components. So if you have those key value pairs, it will break them up so you can easily access them. And then with the second function, you can ask what a variable name is and it will return the value of that variable. The rest of the functions you see underneath is basically that which makes those two first functions work. The code for that will be in the GitLab. There will be links in the description, so you'll be able to access all that. I talked earlier about the importance of creating your own personal library, your own personal code base. So my library very originally is called Technical. So I took a couple of functions from this library and put them in here, just to make those two first functions work, and they're all together here within this web.h file. So a convention that I use is whatever is part of the API, it has a 3-letter prefix. You see web underscore and so on. Whenever I have a function that is not officially part of the API but still needs to be inside that library, I give it a single letter prefix. So this is a function you're not supposed to call from outside the library. You can if you think you have a use for it, but you probably don't. Okay, so I'm gonna get out of this, and yeah, let me just write a new file. Let me call it query.c. So I'm going to get the query string here. Oops. This is a double pointer because it's an array of character strings. So I'm going to get 2 variables. If those variables don't exist in the query string, then they'll just return null. So that should be about it. I'm not going to be too fuzzy about the HTML now. This is just demonstrate. I'm going to check if there is a color. If there's not, I'm just going to have a default color of red. I'm going to make this the background color of the page, and then I'm just going to say welcome and then the name of the user, or just simply welcome if there is no user. So let me just compile that. And now I'm going to the browser, and I'm going to do query, and it says welcome, and I have this red background, and if I put in the query string, then I see that indeed this is working, and of course I can decide to put in just one of them, and then it works just fine as well. Okay, so this is how you easily get the data from a query string. So when you provide data to a web page, there's 2 main ways of doing it. You can do it with the query string, or you can do it, you can include the variables in the HTTP header itself. When the client sends a request for a page to the web server, it can include the variables, the data in the HTTP header, and this is known as the post method, whereas if you use the query string, this would be known as the get method. So I have ways of dealing with that as well. So in order to get the variables with the post method, I have added a function here, web get post string, and it does exactly the same thing as this function, web get query string, except it deals with the post method instead, and it's used exactly the same way as the one with the query string. So I'm just going to literally copy query.c to query post.c, and then here I'm going to change one word, and now it's going to use the post method, and I don't need to change anything else here. I know that this implies it from the query string. It's not the best name for the function maybe, but it's just handy that everything else works the same. Okay, so now all I need to do is compile. There we are. And in order to test this, I've made locally a form. So if we just look at the code that makes up this page, you can see it's very simple. We have the post method that is being used. It will go to that query post web page that we have, and there are two variables, user and color. So all I have to do now is fill this in. I feel like using medium sea green this time, so I will commit, and then there you go. This works fine with the post method as well. So when we look at what you can do so far with this humble web.h, we can print a header, a simple HTTP header. We can print a header to relocate to another page. We can use the query string, and we can use variables which are sent with the post method. There's a lot more you could do here. What about cookies? Right? Let's have a look at cookies. So the thing about cookies is that there are legal issues surrounding them. Especially here in the EU, you have GDPR, which deals with privacy protection of EU citizens. And this is why you might have seen on various websites a request to accept the cookies. Now, I am a computer programmer. I am not a lawyer. I am not a solicitor. So I am not going to tell you what to do or what not to do. I am only talking about the technology, and it's up to you to make sure that you comply with whatever you're supposed to comply with. In order to avoid a lot of hassle for myself, I don't actually use cookies on my website. So I am going to use them now just for demonstration purposes, but again, it's not something I normally do, and it's not part of my web library. So I have a piece of code here I will show you. So this deals with cookies. So the cookies are basically implemented in the HTTP header. So you simply say, this part here you might recognize as the HTTP header we had earlier. You just add a new line, and then the statement set cookie, and then whatever the data is that forms your cookie. So then there is an environment variable. This is to retrieve the cookie afterward. An environment variable HTTP cookie, and then I simply display that. Oops. Alright, so then I simply display that cookie. So if I compile this now, and then if I go to the website, then by what I noticed, by going to that URL, I get the hello world printed, and then it tells me there are no cookies. So when this browser Firefox first made a request to my web server to see that web page, there was no cookie included in the HTTP header, and so the code said, well, there is no cookie. In the response, as the web server sent the web page to the browser, it included in its HTTP header a cookie. So now Firefox has in fact stored a cookie. So what will happen the next time I go to that website, so I can just refresh here, now it will tell me there is a cookie, right? Firefox has included, the second time it has included the cookie in the HTTP header as it made a request to see that web page. Okay, so this is a very simple way of dealing with cookies, and obviously there's a lot more to it, but that should give you the basics. So what we have done today is we've seen the HTTP header, we have seen how to put a cookie in there, we know how to deal with the query string and how to deal with post data. So that should be all your main bases covered. You have all the fundamentals. You have the code of my web library. I will put the link to the GitLab in the description below. So you basically have everything you need now to get started and design your website in C. So I hope you found that useful. I hope you enjoyed it. I hope you learned something, and thank you for watching. Also, if you enjoyed this, please like and subscribe. It really helps me out. I appreciate it. Thank you.